Hi, welcome back into today's video, a continuation of what we've already studied about the similarities. The previous video, the link down here can be able to use to follow it up. And for those who are joining us, I think please do so, because you may not be with us for what we're going to do here in the next section here. So please use the link to at least update yourself of what we've discussed previously. Right, so now to make it short and simple, in this video, we are just simply going to practice what we yielded up in the area discussion. So maybe just to come up with what we had in the previous video, we were trying to compare the ratios here about the similar figures. Right, so from what we yielded out, we really saw that if we are considering out the ratios over top of the corresponding sites of similar figures in relation to ratio over top of the areas. This is what you should always expect to have, right? The ratio of the corresponding sites in our discussion here is described as the linear scale factor. So I'll be talking of the LSF. You have to understand that here we're talking of the ratios of the corresponding sites, okay, of the similar figures. And the description we have for the ratio of the areas, this one is known as the area scale factor. So when I talk of area scale factor, I'm trying to talk of the ratio of the areas. So what we observed was just like if you are to compare the two, LSF and the ASF, you always realize that the square of the linear scale factor, you square that one is always going to give you the what? Area scale factor. So please master this one out. So in this video, I'll have some questions that we need us to practice together so that we have to master this concept. It's just like how do we use these ratios to work out the problems related to the similar problems. Right. So now let us have the problems. So as per requirements, as usual, you may also allow me to raise this one out because of space. Moreover, I've already seen that what we're doing here is mathematics. So please let me remove that one out first. Right, so encouragement is also there. Copy these questions and then follow the discussion, but do not memorize, just see, master the way we approach these questions by the knowledge we have just discussed. Right, not difficult. Right. Okay. So let me first of all have this chart here. Of course, question 2 continues. So I'll bring another chart that will connect to this one. Because of space, let us work first of all on question 1. Then we'll come back to question 2. We'll have another chart that will continue the remaining part of the question. Right. Here we are. We are told that we have got two similar triangles which have their corresponding length in the ratio 2 to 3. Find the ratio of their areas. That is the question. Secondly, given that the smaller triangle has an area of 20 square centimeters, calculate the area of the larger triangle. Yeah, so a good question as such is really within the range of the similar figures. Right, so now here, as much as you are told about the talk of the ratios of these two figures in terms of the corresponding sides 2 to 3, you as a student, the first thing that you need to do, you should be able to at least remember about what we need to know about the what? Ratios of similar figures. So it means the knowledge about what we have just introduced in the previous video about the comparison in relation to the areas of similar figures and the ratio of the corresponding sides has to always be there, and that's the better approach that you can be able to use in order to defeat this problem. Right, so like here, just to give you a good guidance, you'll be able to see that what you know now is just like the linear scale factor compared with this area. Talk of the scale factor is that this one squared, it gives us that one. Right, but now here in the question, what we are told is just like we are given the a triangle. For example, we have got this triangle here and another triangle there, things like that. It means that one is large, another one is smaller. So obviously this one is a smaller one, this one is a larger one. Right. So if we say that we're talking about the ratios of the corresponding sides, right, you may be able to talk of maybe this one, there's a certain one, value, which can be described as maybe x, right? And this one has got a value, which is maybe y. But now if you take the ratio of these two sides, talk of the x to y, in this case, this one is equal to what? Talk of 2 to 3. Or you can write it as what? Talk of 2 to what? To 3 in that manner, the same. That's what we are told in this way. So as much this one has been mentioned, talk of the corresponding sides is 2 to 3. And in your case, you know that if we compare this ratio to the ratio of the areas, you know for sure that the ratio of the talk of the areas is just equal to the square of the ratios of corresponding sides. To mean to say, just like this what you are given here, this one is a linear scale factor, and what we are asked here is just like the area scale factor. So the question here, simply in A, is just like asking us to work out the what? Area scale factor. So you know this, you know this one out by what we have already done in the previous video. So I don't think if you can find some problems to work out the solution to question A. Right. So what you do here, you do just have to consider this what you are given and what you know. So this what you're given here is the area scale factor. And what, sorry, is the linear scale factor, this one here. And what you like to find here, according to the question, is the area scale factor. So if you are to work out the value for this one, what you have to do here is just a matter of, first of all, giving us the relationship here of the two talk of what ratios, right? One ratio you have here is just like you talk of the linear scale factor is equal to 2 to 3. And what you need to work upon here is the now area scale factor. Right, so here if not, you need to work out the area scale factor. That one we know for sure is just the square of what? The ratio of the areas of corresponding sides. So what I'm going to do here is just a matter of trying to square 2 to 3 like that, because this one is what is going to give me this one out. So it means the area scale factor is equal to the square of 2 to 3. So what I'll get here is just what? 4 to 9. Something like that. So that if I'm now to come up with the response to A, find the ratio of the areas. It means what I'll do here is means just like the ratio of the areas. This one will be equal to 4 to 9, which can be written in that way as 4 to 9. This is the response towards that. Right. So I think with this, you may be able to appreciate how the knowledge about the comparison of the two ratios is being used to work up the problems about the what? The areas. So here we are working about, we are working on the what? On the ratios of the areas. So if the sides have the ratio of 2 to 3, it means the areas we have the ratio of 4 to 9. That's the way we do it. Right, now let's go to question B. Question B is asking us to find the area of a larger triangle, given that the smaller triangle is given as 20 square centimeters. Right. So in the same vein as we have done with A, the same knowledge about the comparison between the two ratios, linear scale factor and area scale factor, the knowledge of which will be able to help us to calculate up the area of the larger what? Of the larger triangle. Right, so what I'm going to do here is just like the same analyzation, which can be written in different forms. Right, to say, since first of all here, we do not know the area of the larger one, you know the smaller one, you first of all have to represent the area itself by a certain variable because it's unknown. So you come here and indicate to say, let the area of a of the large or larger, let's say triangle B, represented might be by X. Right. So once you have done that, then try to use the knowledge of what we have discussed about the linear scale factor and area scale factor. Right? So here, what you're given, you'll be able to talk of the area. Let's first of all begin by the linear scale factor. In this case, you are given us 2 to 3, so you write it 2 to 3. And then here, to work out the area, you need to bring in the ratio of the area themselves, where now we are going to use X and a 20 to come up with the area scale factor. So which means in this case, you have the area scale factor as, so you begin with the, since here the scale factor begins with the smaller value to the larger value, so you're also going to consider the smaller area versus the larger area. So the smaller area here is 20, and this one should be 2x in this case. Right, so area scale factor is 2 to 3, and the, linear scale factor is 2 to 3, and that of the area scale factor is 22x. So if we're going to compare the two, what the relationship between the two, you'll be able to conclude that is to say, if we are 2 square, that's 2 to 3, this one squared, it gives us 20 to what? To x. Right. So the same knowledge about the area scale factor, the linear scale factor, which we have introduced area, is also going to give us an equation of that kind. So from this, what you have here, it's just a matter of working out the value of x in this equation. Simple as that. So let us now find the value of x from this equation. So from here, you can try to square this fraction, and the outcome of it will be 4 over 9, which is equal to 20 over x. And if we can try to cross multiply, we'll be able to see that x is multiplying the 4 and 9 is multiplying a 20. Then that will be like 4 times x. It gives us what? I talk of 4x. While here 9 times 20, it gives us 180. Right, when you cross multiply, that's what we get. And then to find the value of x, what is it that we're going to do? You simply divide both sides by x, divide by 4, divide by 4 in order to find the value of x. So 4 gets here into 4, 1, and what will remain here is x, and we'll read 4 into 18. 4 gets into 18, toggle 4 times it, and the 4 into 20, that one gives you a toggle of a 5. 4 into 18, that is 16. It means 2 into 20 is a 5. So which means in this case, x is equal to 45, while x is representing the area of a larger rectangle, triangle. Then you conclude as to say area of larger triangle is what? 45. square centimeters. That's it. So you see, you just compare the two ratios and then you do the substitution accordingly, and then after you just solve the equation that you obtain, and the value you get are the ones which are there giving a response to your problems. Right, so that's it. Can we now go to question 2? For question 2, of course, the continuation of that. Let me just have it here. The other part is not all that part of this. I'm trying to hide the other part, which will come later in our discussion. Right, so let's just focus on this first. Aha. All right. Okay. All right, the next question goes like this. So let's just blank this one out. You know, the space is not all that enough, it's very small. Here we have the triangle ABC and the triangle DEF. We are told that the two triangles are similar. So it may be just a tentative plan to draw the sketch of which we may have that this is a triangle here and another triangle here, things like that. So this is triangle ABC and this one is DEF. The two triangles are similar. Right, now if we are told that if the area of triangle ABC is that one, that is 9.8, and the area of triangle DEF is 5.0 square centimeters, to mean that this one, the area is equal to 9.8, and here the area is equal to 5.0, just simply 5 square centimeters. What is it that we need to work out? We are asked to find the value of the ratio of AB to DE. Right. AB to what? DE. AB to DE. That's it. So from the lookout of things here, you may be able to analyze, that's to say, if we are asked to find the ratio of the two sides, AB to DE, it simply means we are asked to work out the value of the linear scale factor. Like AB is the side that corresponds to what? DA. Right, so these two sides are corresponding. Now in that ratio, that's just like a linear scale factor. So somewhere, if you can look at this, it's still about the area scale factor, the linear scale factor, such that you just have to coordinate your knowledge within this understanding. You'll be able to work out on that and be able to analyze that, say whatever it is here is about the relationship that is there between the area scale factor and the what? Linear scale factor. Right. So here the question is finding A, B to D, E. So simply find the linear scale factor, the ratio of the two. Right. We are given what? 9.8 as area, and the 5 as what? another area of another figure. Like if I may attempt to get the what? The ratio of the areas of the two figures, definitely that will also give me what? The area scale what? Scale factor. So just like I have here in this question, issues about the what? Area scale factor and also the what? Linear scale factor. The question, if I'm to analyze it, you find that this question is asking me just to find the what? Linear scale factor. So as a student, you can be able to coordinate the knowledge here and be able to find the ratio of AD to what? To DE. AP to what? DE, which is just like the what? Finding the what? The linear scale factor. Right. So one way how you can do it, I know most of you where you are trying to at least skip somewhere and be able to calculate the linear scale factor of which in this relationship. Right. So from what we know, it's like the moment I compare a linear scale factor, that is always the starting point. Right? But that these issues are concerned. That is always the starting point. Always produce the relationship between the ratios of the corresponding sites and the areas. So what I know here, I know that say the square of the linear scale factor is equal to the what? Area scale factor. That's say if I square that. That's what I know at that. So what I want to find here is the linear scale factor. AB is the side of triangle AB. And the DE is the side of the what? Triangle DEF. Right. So what is there is like linear scale factor in this case is more like LSF. In this case, this one is thus supposed to be substituted by AB to DE. So instead of writing LSF according to what we have in the question, I'll just indicate AB to DE, this one squared. It gives us what? The area. That's area scale factor. So here the areas we are already given as 9.8 and 5.0. Right. So if here I'm to substitute for ASF, it means where I have got ASF there. Since here I've already started with this triangle, which is larger than this 9.8, then it means here I'm also going to start with the 9.8 as this one here, this one will be on top, 9.8, then 2, 5.0. That's the way I can analyze what we have here. So linear scale factor versus area scale factor. Linear scale factor squared is equal to area scale factor. So if you talk of linear scale factor is as good as just substituting for AB to DE. For the area scale factor, is just substituting that one for 9.8 to 5.0. Right. Then from there, you'll be able to calculate the ratio of AB to DE. Right. So how do we do it? What we have there, we need to eliminate the 2, and then once we eliminate the 2, the result, it will be AB to DE. So how do we get rid of the 2? Here, since this one is being squared, in order to remove the 2, we have to take the square root on both sides. So what we have here, it means that if I take the square root of this left-hand side, I'll have my AB to D top of A. When I'm taking the square root on the one side of the equation, I have to do the same on the right-hand side. Measure done on one side of the equation should be the same for the other. So here it means I'm also going to take the square root of what? 9.8 to what? 5.0. Right. So as the decimal fractions here, it's a problem. Somehow a little bit difficult to wake up the square root of which, but still we can find them. So what we do here, let us now try to get rid of the decimals, right? So you can prefer to multiply both numerator and denominator by a 10. So if you multiply that numerator 9.8 by a 10, what you get there is just 98, but here you're going to get a 50. Right. Continue with that, you will be able to appreciate that say on the right-hand side, if we keep on simplifying, we are going to obtain this value. Right, that is to say 98 over 50, you can divide 98 and 50 by a common factor, which is a 2, such that your equation now will turn out to be A, B to D, E is equal to square root of 2 into 98 is 49, and 2 into 50 is 25. So if I talk of AB to DE, is simply the square root of the 49 to 25. And what I get here is just like AB to DE is simply equal to what? 7 to 5. Right. So about what we have been asked to find the value of AB to DE, it's just like self-explanatory. Right, so from there, just conclude as to say, here, the moment I've found the fraction AB to DE is equal to 7 to 5, then I'll be able to conclude that to say, therefore, AB to DE, that is simply equal to 7 to, that is 5. Right, so at least, we might be in the right channel now to understand what it is about what we are doing in the similarity. It's just issues about the ratios of the two constants. One, corresponding sides, and the areas. But now of only figures which are similar. Right? Having known the ratios, linear scale factor and area scale factor, how do you then use them? This is just like the two good examples that have given us a direction on how these ratios can be used. Otherwise, thank you very much. Just wish you all the best in your revision. Always, I know you cannot pick up the concept at the same time, but with continued study and the revision, you'll be able to be in the right track. So I still more ask you to play these videos now and again until you get the knowledge and be able to be clarified. Next will be a video that will give us the last section of the topic, that is now issue about the volume, where we're also going to compare the volume scale factor versus the linear scale factor. So this is language I think now is not new to you. You are there and just wait what will be there. Right, thank you very much and meet in the next video.